Here we're going to go over how to create a graph on Excel, how to put a line of best fit on that graph, and then also plot what are called error bars. To do this, we have a set of data. Here are our X values right here, which are just going to be simple numbers 1 through 8. And we've done a set of measurements of a Y value. The Y values vary from trial to trial. And what we want to do is draw a graph of the average value for Y against X. So the first thing we need to do is calculate some numbers. So what we're going to do is right here, in this column right here, we're going to calculate the mean value of these. To do that, we're going to use the Excel function called average, which is just average spelled out, then open parentheses. And inside these parentheses, we need to put the numbers we're going to calculate the average for. So what we're going to do is click and drag and select the numbers we want to calculate the average for, then hit close parentheses. So we've selected from cells B4 through G4. We hit enter, and here's the average value. Now I want to do that for each set of these values. So what we're going to do is just copy this formula down by moving the cursor over to the corner right here till it turns into a dark cross, and then just drag it down. That formula is now copied into all of these cells. So this cell right here has the average for the numbers in that row. Likewise, this one has the average for the numbers in this row. So now we have all of our average values. And we're going to plot X on the X-axis and the mean values on the Y-axis. We also want to have our error bars. Our error bars are going to be the standard errors for each of these sets of measurements. To do that, we need to calculate the standard deviation. I'm just going to abbreviate that as STDEV. And we're going to use the Excel function to calculate standard deviation, which is STDEV. Then we open parentheses. Oops, typo there. DEV. And then we click on the numbers whose standard deviation we want to get. Whoops, I don't want the mean value. So again, the same B4 to G4. Close parentheses and enter. There's our standard deviation. And again, we move the cursor over to the corner right here until it turns into a dark cross. Click and drag. Now we've calculated the mean and standard deviation of all of our data sets right here. We don't want to use the standard deviation. We want to use the standard error. And the standard error is just, again, put an equal sign. We want this number right here, the standard deviation, divided by the square root. The square root function is SQRT, open parentheses. Now we want the square root of the number of data points. Excel nicely has a function called count, which will count the number of cells in a given selection. So I'm going to select where I have the data. This will then count the number of data points. So it happens there's 1, 2, 3, 4, 5, 6. So the answer is going to be 6. But this is just a neater way to do it. So you have to close the parentheses for the count, close parentheses for the square root, and then we hit enter, and there's the standard error. Convention is actually not to plot the standard error, but rather the standard error times 2. So that means there's approximately a 95% chance the real value is somewhere within plus or minus 2 alpha of the mean value. So I'm going to multiply that by 2, and I'm going to use that for my error. I'm going to take that formula again, copy and paste it all the way down here. So this is going to give me my error bars. So now I want to create a graph. To create a graph, I need to select my X, which has to be the first column I select. Now to select my Y, on an Apple, I hold down the Command key. On a PC, you hold down the Control key, and you select the Y values. So I have this goes on the X-axis, this goes on the Y-axis, and it has to be in that order. And then I want to insert, so I go up here and select insert. These are the different graphs. I want a scatter plot, so I'm going to select an XY scatter plot. All I want are the points, so I'm selecting that right there. And here's my graph. And I'm just going to move the graph so that it's not covering my data. Now, We could take and change the title here, and we also can, for an example, add axis titles for the horizontal and vertical axes. I'm not going to do that right now. You can easily do that. And right here's the title for the graph as a whole. And you can change other things. What I mainly want to do first is just put on a trend line. I want lots more options than they give right here. I don't just want to draw the line. So I'm going to select this so I get all the options. So over here I get the different options. These are the different types of trend lines we can do. This data looks like it's linear, so I'm going to use a linear plot. However, in addition, I also want to display the equation for the graph and the r-squared value for the graph. So I'm going to close that. Now this right here is kind of an inconvenient place. I'm just going to move it over here. And just in order to make it look a little prettier, I am going to put a box around it and fill it in with white, so now it stands out. So my equation for the best fit line is y equals my slope times x plus an intercept. And it gives me an r-squared value of 0.991. What that r-squared tells me is how much of the variation in y is explained by this line. In this case, it's 99.1% of the variation in y is explained by a linear relationship with x. If, for an example, my overall precision for my experiment was my data points were good to within a few percent, then I have explained 99+% of the variation. And if my uncertainty is, say, a couple of percent, the unexplained 1% could be interpreted as the uncertainty in my measurements. On the other hand, if I made my measurements with incredible precision, down to a fraction of a percent, then I haven't explained all the variation, because I've explained it about 99%, but if my uncertainty is much, much less than 1%, something else must be going on, and we'd have to do further investigation. Generally speaking, a 99+% is what we're looking for. Our measurements, generally speaking, will be at least a percent or so. So this would say that we've explained all of our variation by this straight line. But we still do have some errors, so what I want to do is show how these errors right here can be displayed graphically on this chart. To do that, what we're going to do is select the data set right here, and then go to Chart Design. We're going to add another element. Down here, one of the options is error bars. Now, what we're going to do is, again, go to the More Error Bar options. And notice we can draw error bars on the top and the bottom. We want both. The style I happen to like puts a little cap on the top of it. That just makes the error bar, I think, a little bit easier to see. These are the default types that Excel provides you with. None of those are terribly useful. You might see standard error and think, ah ha ha, isn't that what we want? And the answer is no, it's not. We want us to do a custom one. We're actually going to specify the value. And what we're going to do is select the values that we have right here, our standard errors. We can actually change a different one for the positive, the top side, and the negative, the downside, but we're going to use the same one. So what we're going to do is right here, click on this button right here so we can select a region. We're going to select our standard error, and we're going to do the same thing. Click on that, select the exact same thing. Plus and minus will be the same, and accept that and go OK. That now sets our error bars for Y. We're going to take X in this example as being precise. That might just be a count. Excel, for some reason, always sticks in an error bar there. We don't want it. So I'm just going to select the error bar and then hit the delete button to get rid of the X error bars. And then close this. So there's our graph. We have our data with our error bars and our line of best fit and the equation of the line of best fit. This is the kind of thing you're going to be doing in virtually every experiment we draw graphs. Only other thing we might want to do is this graph is kind of small. What we can also do right here is move the chart. Rather than showing it as an object in this sheet, we can put it on a sheet all by itself. That'll simply make the graph bigger and easier to read. So now we can actually see the error bars. And this would be our final graph.